Hey, Aaron Rabinowitz here for RedGiantTV.com. 4 years ago, Chris Zwar did an amazing 3D animation generated almost entirely in Adobe After Effects, and you're seeing some of that on your screen now. Even today, as an After Effects 3D project, it still holds up as one of the best examples of After Effects 3D in use. Chris did a 3-part tutorial breaking down the Centrica project, which you can find at the Pro Video Coalition, and I'll show you how to access that a little later. Originally from Melbourne, Australia, Chris started work in entertainment media in 1997 and since then has worked in video editing, directing, show development, and animation. He currently freelances in Sydney, Australia as a freelance After Effects specialist. In this tutorial, Chris is going to break down one of the coolest and perhaps most uber-geeky aspects of his Centrica project, creating those carnival-like flashing lights with all of those interesting behaviors. Take it away, Chris.
Thanks, Aaron. I'm Chris Zwar, and welcome to my first contribution to Red Giant TV. Today we're looking at how to make lots and lots of lights flash on and off automatically, with a focus on the automatic bit. We're going to walk through a simple expression step by step and talk about how it's working and why. Apologies to those of you who aren't really into expressions, but what I'm trying to do is make it informative and interesting for everyone who doesn't normally use them. Before we get into the technical details, I'll just do a quick recap of how we create the lights themselves. If you want the full details, then check out the tutorials that Aaron just mentioned, because this is just a pretty quick overview. I'm not actually flashing the lights by changing their opacity. I'm actually swapping between two different photos of a real light bulb, one on and one off. So here I have a sequence that contains the two photos. Each photo is 1 second in duration, and this pre-composition is what I use in my main composition every time I need a light bulb. We use time remapping on each layer to swap between the image of the on bulb and the image of the off bulb. Now you may have thought that time remapping was only good for slow motion effects or ramping up the speed of video, but we can also use it as an organizational tool. By animating the time remapping value between 0 and 1, we're switching between our two different photos, but we're only using one layer in the comp. So this gives us the illusion of a single bulb that's flashing on and off. I've constructed a simple 3D background in After Effects, and I've set up a 3D camera with a simple pull-out move. So what we want to do is incorporate our flashing lights into this scene. So we're working in 3D, and that means that each light bulb will be an individual 3D layer positioned in 3D space. This means that if we want lots of flashing lights, then we'll end up with lots of layers. Possibly lots and lots and lots of layers, which, by the way, is why the photos of the light bulb are so small. They're about, I think they're 100 pixels square. Because I've built a 3D environment, there are two main advantages of having each light bulb as an individual layer. Firstly, I can hand position each light in 3D space exactly where I want it. And secondly, I can set the light bulbs to auto-orientate to the camera. This means they're always facing the camera, and so they appear to be more 3D than they really are, even as the camera rotates around the scene. If this is not turned on, then they disappear when they're side on. So having them auto-orientate to the camera is a trick that works for anything round, because with a sphere, all spheres look the same no matter which side you view them from. Because there are so many layers, I've used expressions to automatically position the lights for me. And by linking everything together with sliders, it means you can easily adjust the position, the arrangement of all the lights together. I've also linked the scale of each light to a central control slider, just so they can be resized together. It just makes it much easier to control the look of the scene. We can wrangle hundreds of layers if we need to, all simultaneously just by dragging a slider. This is something which I'll discuss again later on. The photos of the light bulbs look pretty good on black, but they don't work so well on other backgrounds. They're hard to see, and they definitely don't look like they're lighting the scene. So the Knoll Light Factory is used to give the composition a boost, and it helps everything look a lot more real. The Knoll Light Factory plugin is absolutely essential to the look and feel of these projects. Knoll Light Factory Pro comes with several plugins, and the one which we're using is called Light Factory Spectacular. This plugin looks for dots on a location layer and automatically places a lens flare on each of those dots. And the lens flare can be bigger and brighter depending on the size of the dot. So basically, the size and position of the dots in the location layer governs the size and position of the lens flares. Now, the photos of the light bulbs don't work very well as location dots, mainly because the photo of the off bulb is the same size as the photo of the on bulb, but we want the lens flares to be a different size for the on bulb than from the off bulb. So what we do is we create a duplicate sequence, which is the same as the one we've got with our two photos of the light bulbs, but we have small solid circles instead of images. So we can have a small circle for the off bulb and a large circle for the on bulb. And when we've positioned all of our light bulbs in 3D space, we duplicate the composition, and then we just use the Alt-Drag function to replace those photos with the location dots instead. And this gives us a lens flare location pre-composition, which we can use as the location layer for the Knoll Light Factory Spectacular plugin. And it might seem messy, it might seem like there's lots of steps to go through, but the result is worth it. Knoll Light Factory Pro is absolutely essential to the final look. In this example project, I've even split all of the lights into 3 different location layers, and I'm actually using 3 different settings with the Knoll Light Factory plugin. I've mixed 3 different types of lens flares with a few different colours just to make the scene a bit more interesting with a bit more variation. The Pro Video Coalition tutorials cover these steps in much more detail, so let's move away from the way the light bulbs look to how they flash on and off. As I mentioned before, it's just not feasible to animate hundreds of layers manually, so we'll use expressions instead and they'll do all the work for us. Our light bulbs are animated by changing their time remapping value between 0 and 1. So, we'll apply an expression to the time remapping property, and by designing an expression that changes between 0 and 1, we'll have a light bulb that flashes on and off. So the intention is to create a single expression that we can paste to every light in the composition and then have them all flash automatically. So, this is how I started. The first thing to do was to actually just stand back and analyse what we're trying to do. When we see a strip of flashing lights, there are 2 things going on. Firstly, at any stage, some of the lights are on and some of the lights are off. And secondly, which lights are on and off alternates over time, hence the flashing. This means we need our expression to do 2 things. Firstly, to determine if a light bulb is on or off to begin with, and secondly, to alternate this over time so that the lights flash. In terms of translating these steps into expression code, we can actually use the same function to do both of these jobs for us. And that's the Modulo function, which is represented by the percentage sign. Because it's doing all of the hard work, let's take a closer look at what exactly the Modulo function is. There are several different ways of describing what the Modulo function does, but perhaps the easiest description is that it loops or cycles numbers around a value that you set. Working with the Modulo function is sometimes called clock arithmetic, because it's the mathematical equivalent of a clock. When a clock gets to 12 o'clock, it starts again from 1. The time wraps or loops around, begins again. The Modulo function does the same thing, but instead of 12 numbers, we can define how few or how many we want. We give the Modulo function a number, we tell it how many divisions are on our modulo clock face, and it tells us the time that it would be on a clock with that many divisions. The only real difference is that the modulo function starts from 0 instead of 1. It doesn't matter how big the number we start with, the modulo function will always return a value that's smaller than the number of divisions on our modulo clock face. So, getting back to light bulbs. Our first step was to figure out if the lights are initially on or off. What we're trying to do is alter every second light bulb, so we need a way of identifying every second layer automatically. When we want to identify a layer in After Effects, we can use a layer number. Every layer in a composition has a unique layer number. They start at 1 and they go up depending on how many layers you add. When we have a sequence of numbers, every second number is either odd or even. So, with a composition full of light bulbs, we can look at each layer number and calculate if the layer number is odd or even, and use this to determine if the light is on or off. So in other words, by making all the odd layers on and the even layers off, or vice versa, every second light will automatically be on or off. So, in After Effects expression terms, it's easy enough to get the layer number. We just use the index function. It's just the word index. But how do we determine if it's odd or even? Well, that's where the modulo function comes in, because the easiest way to calculate if a number is odd or even is to use the modulo function with a value of 2. In expression terms, we start with the layer number, identified by the word index, we use the modulo symbol, and then we specify a modulo value of 2. We now have an expression that returns a value of either 0 or 1, depending on whether the layer number is odd or even, which is exactly what we need. We can even copy this code and paste it to all of our layers, and you can see that it's doing exactly what we want to do. It's turning every second light on or off. So we're halfway there. It's a good start, they're just not flashing yet. Currently, all of the even numbered layers are on and the odd numbered layers are off. We just want to alternate this periodically to make them look like they're flashing. To make the animation change over time, we'll use the time function. The time function is simply the word time, and it returns the composition time in seconds. So 1 second is exactly 1, 2 seconds is exactly 2, and all of the frames in between are returned with necessary decimal places. We can use the same approach that we just used with our odd and even layer numbers, but instead of looking at the layer number, we'll look at the composition time in seconds. So if it's an odd number of seconds, the odd layers are on, and if it's an even number of seconds, then the even numbers are on. And this way, our lights will flash automatically once per second. So once again, we use the modulo function with a value of 2 to determine if the time is an odd or an even number. However, in this case, there's an additional step involved. Because the time values between each second have lots of decimal places, they're technically odd numbers. We have to remove all of these decimal places first. We just want the composition time in whole seconds without the fine detail. We'll use a maths function called floor to do this for us, which rounds a number down to the nearest integer. Gets rid of all of those decimal places, so it's exactly what we need. Now, to make our expression clear and organized, I'm going to separate the different steps into different lines. And I'm going to use a variable called t. I'm going to use the letter t to store the value of the time function between all of our different steps. Now, this isn't strictly necessary. It's just clearer to look at. It's a useful approach if you're a designer and not a programmer. We could combine all of our expression functions into one line, and it would look like this. And it would work perfectly well. But not everyone who uses After Effects is a programmer. So if we keep our expressions clear and methodical, then it's easier to see exactly what's going on. So let's get rid of that ugly complex line, and we'll break down our process over a few lines. Firstly, let's just start by copying the composition time into a variable. We'll use the letter t, t for time. It's a little bit like high school algebra. Then we use the floor function, the math floor function, to remove the decimal places and copy the result back into our t variable. So the letter t now represents the composition time in whole seconds. Next, we use the modulo function with the value of 2, and that converts our letter t into either a 0 or a 1, depending on whether t started out as either odd or even. And finally, we'll now use an if statement to compare that result with 0 or 1, and if the result is 1, we change the value of our light bulb. The light bulb value, which is also a 0 or a 1, is reversed by subtracting itself from 1. Basically, by subtracting a 0 or a 1 from 1, a 0 becomes a 1 and a 1 becomes a 0. Now, there are several other ways we could do this, but this is a nice simple method that doesn't involve any fancy logic or any fancy symbols. So what we have now is a virtual switch that turns on and off once a second. So if the time is an odd number of seconds, only the odd layers are on. And when the time is an even number of seconds, the even layers are on. So this basic expression gives us flashing lights that automatically flash for as long as the composition is rendered and for as many layers as we have. We can now take our expression, we can copy it, and we can paste it to every light bulb in the composition. Now, today's more about the expressions and not so much about the appearance, because the tutorials that are over at the Pro Video Coalition cover everything else in fine detail. But just to quickly recap, this is what I do next. I keep all of the light bulbs in their own separate composition. And I use the collapse transformation switch in the main comp to preserve all of their 3D attributes. So now all of those light bulbs, even if there's hundreds and hundreds of them, they're all represented in our main composition by a single layer. I want these light bulbs to auto-orientate to the camera to make them look more 3D than they really are. However, for this to work, I need to copy the camera into the light bulb composition. But once I've done that, I can select all of the lights, I can change their auto-orientate settings, and now they're looking a bit more 3D. The next step is to take this pre-comp and duplicate it, and then replace all of the light bulbs with those location dots that I mentioned earlier. So now I have two matching compositions. One has an image of the light bulbs, and the other has dots for the Knoll Light Factory plugin. And finally, in our main composition, I can now apply the Knoll Light Factory Spectacular plugin. I can set the location layer accordingly, and then I can adjust the lens flare settings, and everything looks great. So, now we've got some simple flashing lights. So far so good. However, the problem is that having every second light bulb flash on and off is a little boring. So what else can we do to make them look a bit more interesting? The expression we have at the moment looks at the layer number and determines if it's odd or even, and that's determining the flashing pattern we see. Every second number is odd or even, so every second light is on or off. By using slightly different selection methods, we can get different patterns. And the methods we'll look at here are comparing the layer number against the composition time. For this approach, we're going to use a different method of counting time. Rather than use the plain time function, that was just the word time, that counts in seconds. What we're going to use this time is the time to frames function. And this counts off each individual frame of the composition. So frame 0 is 0, frame 1 is 1, and so on. So the time function is simply the word time. The time to frames function has several additional parameters. Now, you don't need to know them, you don't need to know what they do. All you need to do is choose time to frames from the shortcuts menu. The default values work fine. So it's not nearly as complex as it looks. All you have to do is click time to frames, and there you go. To get a different flashing pattern, we can compare the composition frame number with the light bulb's layer number. And we'll use another if statement, similar to the one we used earlier, to make the comparison. When we compare the frame number to the layer number, we can use an equals sign, and this will make sure that one bulb is on at a time, every time that the layer number is the same as the frame number. Or, alternatively, we can use a less than sign, and this way the bulbs will stay on as the frame number increases. We can see this with a strip of 10 lights. So when we use an equals sign, each light bulb is only on when its layer number matches the composition frame number. So at frame 1, light bulb number 1 is on, and in frame 2, light bulb number 2 is on, and so on. And then when we use a less than sign, the lights stay on, they don't turn off. It might sound kind of complicated, but I'm sure you can see the difference here with these two strips of lights. But what happens after frame 10? All of our lights are on, and suddenly there's no more animation. Well, the solution is to go back to the Modulo function we used earlier, and we'll use it with our time to frames, our frames counter. And by setting the modulo value to being the number of light bulbs we have, the frames counter will cycle over and over and over after it gets to the last bulb. Now, remembering that the modulo function is like a clock, so in the same way that the clock gets to 12 and starts again from 1, in our case, the frame counter will get to the number of lights we've got in the composition, and then it will start again from 0. We can even set this value to the number of layers in the composition automatically, and that way the value will change by itself as we add or delete lights to the comp. I'm actually adding an extra 1 here in this version just to give us a complete frame, kind of like a 1 frame breathing space with all the bulbs on before they turn off and start again. So there's one final thing we can look at. Let's go back to our original strip of lights. Currently, we're using a simple on-off pattern that's based on odd and even numbers, and the odd and even numbers are calculated by using a modulo function with a value of 2. But there's the potential that using a different modulo value will give us different patterns. Maybe we're thinking, what happens if we use a modulo value of 3 or 4 or even more? Now, it's pretty easy to try, but the problem is it gets really tedious to kind of change our expression, copy the expression, paste it to potentially hundreds of layers at a time, and then see if it works. And then if we want to change something else, we have to go through that whole process again. So we can do it, well, it's just not much fun. So what we can do is we can set up a null object as a central control point, and we can link all of our parameters in our expression to it. And that way we have kind of like a central point where we can change every layer in the composition at the same time simultaneously. And this means that we can update hundreds of layers together, and we can see lots of different possibilities just by dragging a slider. So what we need to do is add a layer to our composition to be our central control point. Now I generally use null objects. And then once we've got our null object, we can apply a slider control from the expression controls list. And we just break down our expression, and every time we have a value that we think might be interesting to change, we just add a slider to our null object and use the pick whip to link them up. So we can use if we look at where we've used numbers, there's the modulo number with the layer number. We can, pick whip that to a slider. We've got the overall speed of the animation because we've got our time parameter there. So maybe if we add a multiplication factor there, we can change the speed of the animation. And that way we're not limited to having our animation flash once per second. And so on. And what this means is we've broken down our expressions. Every time there's a number that we think, well, what would happen if we change it? We just link it to link it with a pick whip to a slider, and then we can see. So here we have an expression that's got the same structure as the one we started with. It's fairly simple. However, all of the parameters in this are pick whipped to our sliders. This means that we can just change everything at once by moving them around. To use a Hollywood cliche and to cut to the chase, you're not going to get amazingly complicated patterns, but you do get a few little variations here. So instead of having every second light bulb on, we can get light bulbs that flash on in pairs or in triplets and so on. But the point is that we can try it. We can see exactly what we're going to get just by moving the slider, which it allows you to be creative without getting bogged down into cutting and pasting or thinking too much about maths. So if you go back to the original Centrica project that I completed many years ago, I did use a few different values with the Modulo function, but the basic technique I used is the same as in that initial expression, where hundreds and hundreds of light bulbs were flashing on and off automatically or without a single keyframe. Well, that's it for me today. I hope you found this interesting, informative, and possibly even useful. Thanks again for your time. I'm Chris Zwar.
Thanks, Chris. Awesome stuff. This has given me a lot of cool ideas, and I feel like, I don't know, like a light bulb has gone off in my head. Yeah, you like the way I did that? Yeah? No? Well. Anyway, if you enjoyed this tutorial and you want to learn even more about how the Centrica project was done, check out the Pro Video Coalition website. To navigate to the tutorial, go to provideocoalition.com and then, well, okay, it's actually fairly complicated because there's 3 different links, so you know what, I'll leave the address in the show notes where you found this video. Or you can always just search for Centrica on Google. If you'd like to learn more about Chris and his work, you can check out his site at chriszwar.com. You can find a bunch of cool free After Effects projects there as well. And speaking of free presets and projects, check out redgiantpeople.com for tons of free presets for your Red Giant products. Don't forget you can download a trial version of Knoll Light Factory at redgiantsoftware.com. Once again, I'm Aaron Rabinowitz for redgianttv.com. See you next time.